Agent frameworks go local first. The agent tooling ecosystem continues to bifurcate between black box convenience and transparent production-grade control, and a cohort of open projects are pushing hard for the latter. Flow AI positions itself as a Python framework designed for composable, debuggable agent workflows with open-source inference as a first-class path. It supports VLLM and Llama out of the box, offers vendor-agnostic backends, OpenAI, Anthropic, Google, Vertex AI, and adds open telemetry tracing so teams can see token usage and step-by-step behavior. Multi-agent collaboration, Arium, and YAML-based configuration aim to balance structure with flexibility. The maintainers say Azure integration is in progress. They plan to open source an agent builder and queued execution pipelines next, and they're working to make Flow AI an MCP, Model Context Protocol, client to improve interoperability across tools. At the glue and UI layer, Langflow's first official Flow release, Elephant v10, packages custom components for local workflows, file system access, Playwright-powered web browsing, and a code runner for executing code and shell commands, paired with a tutorial channel focused on installing and hosting open models via LM Studio and Langflow. It's aimed squarely at users who want end-to-end local automation with clean import-export of flows. For media pipelines, FTK Canvas Agent integrates with Comfy UI to turn chat prompts into turnkey audiovisual processing. Intelligent editing, effects, TTS, automatic aspect scene slicing, workflow permissions, and encrypted distribution, plus auto-execution and result delivery. The recently released v1.02 improves agent planning and fixes UI bugs, pushing towards zero configuration, usage, and workflow governance so creators can operate and monetize their Comfy UI graphs without leaking designs. Performance wins, GPUs and kernels. On the performance frontier, a deep dive into Llama.cpp's RockM HIP backend for AMD RDNA 3, tested on Strix Halo Ryzen AI Max 395, identified dumb tile selection and fallback gaps that caused long context slowdowns and occasional crashes. A tuned branch adjusts RockWMA tile usage for better occupancy, adds a guarded vector fallback when tiles are missing, and notably improves prefill throughput at depth while stabilizing decode. The author cautions it's not meant for upstream, a broader HIP RockM overhaul is planned, and that AMD regressions can slip in without CI coverage, but the fixes narrowed long context penalties and made RockM more competitive with Vulkan on RDNA 3. K-Transformers, working with SGLang and Llama Factory, enabled multi-GPU inference and local fine-tuning for very large models, with a notable system-level tweak. Expert deferral. By deferring accumulation of the least important few experts to the next layer's residual path, they increase CPU-GPU overlap during mixture of experts inference, reporting over 30% performance gains while preserving quality in their experiments. With Llama Factory integration, they also demonstrate CPU AMX-assisted heterogeneous fine-tuning to drop VRAM demand, claiming fine-tuning DeepSeek 671B with just one box and two RTX 4090s is now viable. An eye-catching example of system algorithm co-design aimed at local users. PeerLM's 0.7.6 host release underscores how orchestration stacks can translate engineering into user-visible speed. A ground-up host rewrite adds native llama.cpp bindings, reduces startup memory overhead, and tunes GPU utilization and token streaming, leading some hosts to jump from 190 milliseconds per token to 9 milliseconds per token within the network. The release also adds desktop menus, smarter logging telemetry, reduced orchestrator chatter, version awareness, privacy-preserving metrics, and governance policies at the orchestrator level, while positioning for multimodal hosting and API v2.0 for builders. LM security. Structure can bite. A new Arxiv preprint and discussions catalog 41, cross-stage failure modes where LLMs and agents implicitly trust intermediate representations across pipeline stages. The paper highlights that models may treat format as intent. A poem that encodes a malicious action can induce harmful code, form-induced safety deviation. Structured data can be treated as instruction without explicit verbs, implicit command via structural affordance, and benign-looking phrases concede latent session rules that trigger later. Proposed mitigations include stage-wise validation and policy checks, format labeling normalization to prevent format intent leakage, explicit scoping for rules memory, and strict schema-aware guards. The experiments focus on text-only setups, fresh sessions, provider defaults, framing this as architectural risk, not operational exploits. An editorial reminder: prompt injection is for everyone. The piece argues natural language manipulation is now an attack on business logic, not just a jailbreak curiosity. Users are discovering that tone and structure can route chatbots to desired actions, e.g., fast tracking to a human agent, and that ignore previous instructions or even profanity can influence outcomes. The takeaway is not that guardrails are useless, but that they must be paired with behavior monitoring. Baseline the agent's objective and activity, evaluate input intent and the agent's actions continuously, and treat prompts as an auditable input stream. In other words, assume guardrails will fail and build multiple defensive layers, including runtime oversight. Real-world testing backs the caution. One developer found a remote file inclusion vulnerability in an AI-generated app before launch, a reminder that LLM-driven scaffolding can still produce classic web vulns if not rigorously reviewed. On macOS, a practical walkthrough shows how to reverse macOS application type XPC helper protocols and build a functioning Objective-C client, laying out a methodology to probe helper interfaces, a relevant pattern as more apps embed local agents and background services. Against this backdrop, Launch HN Propolis pitches autonomous browser agents that explore your web app and generate tests to keep bugs out, a timely angle, provided the tests cover not just UI-happy paths, but also security-relevant states. New multimodal models in OCR. Qwen 3VL235B A20B thinking pushes breadth in a single system. GUI operation for PC mobile via element recognition and tool invocation. Stronger spatial grounding, 2D and enabling 3D grounding. Long context video and document understanding with native 256K context extendable to 1M. Enhanced OCR across 32 languages, and improved STEM reasoning with more precise temporal alignment. Under the hood, interleaved MROP targets robust positional embeddings over time, width, height for long horizon video reasoning. DeepStack fuses multi-level VT features, and text timestamp alignment strengthens event localization. The repository includes quick start code and recommends Flash Attention 2 for multi-image video scenarios. Liquid AI's LFM2 VL3B continues the small but capable track. A 3B multimodal checkpoint with SIGLIP2 Naflex vision encoders, 32K text context, dynamic image tokenization, and user-tunable speed quality via patch token limits. A hybrid con plus attention backbone, a 2-layer MLP connector with pixel unshuffle, and tiling plus thumbnails preserve global context while keeping token counts tractable. The team recommends fine-tuning for narrow use cases, provides inference parameters, and reports competitive scores among lightweight open models while keeping inference efficient. DeepSeek OCR frames OCR as context's optical compression, releasing a model with HF transformer support, Flash Atten acceleration, and configurable image base sizes from tiny through large, and a Gundam mode with cropping and compression testing. The repo shows a direct infer API, notes PDF processing and VLLM acceleration in the GitHub resources, and targets robust long document structure parsing and challenging OCR scenarios, useful companions to the long context multimodal models above. High-res diffusion, on the image generation side, dynamic position extrapolation, proposes a training-free method to push diffusion transformers to ultra-high resolutions by dynamically adjusting positional encodings during denoising to match evolving frequency content. The authors demonstrate faithful 4K x 4K outputs using pre-trained backbones without extra sampling steps, provide a reference implementation with toggles for baseline yarn NTK comparisons, and note the work is patent pending. It's a clean example of inference time adaptation that leans on signal properties rather than expensive retraining. Meanwhile, a pragmatic, local-first TTS project shows how to extract voice lines and subtitles from Portal 2 and fine-tune CSM1B on Apple's MLX stack using CSM-MLX. The demo produces a GLaDOS-style voice and shares a simple pipeline. The author flags uncertainty about releasing weights trained on copyrighted material, a predictable legal boundary for many hobby TTS projects. Tie this with agentized media pipelines. Projects like FTK Canvas Agent feed comfy UI workflows from a chat interface, adding permissions, encryption, and automated result return. As high-res generation gets cheaper and TTS becomes point-and-click, Governance and workflow protection become part of the product surface, not just deployment details. Embeddings and retrieval advances. The F2LLM technical report targets a perennial gap in local-first stacks, top-tier embeddings without closed data. It claims to match state-of-the-art embedding performance using 6 million open-source data points, a data-efficient route that, if reproducible, would materially lower the barrier to solid RAG systems without commercial embeddings. Strong embeddings only pay off if the upstream perception is trustworthy. That's where models like DeepSeek OCR for robust text extraction from complex documents and Qwen3VL's long-context video text grounding become complementary. Clean text spans and structure, fused with models that can hold and reason over long contexts, help produce higher-quality retrieval targets and summaries. And if you plan to adapt embeddings locally, the K-transformers and Llama factory pathway, mixing GPU with CPU AMX compute to reduce VRAM, offers a practical blueprint for light fine-tuning and domain adaptation on commodity rigs, broadening who can experiment with tailored semantic spaces. Section: DIY Robotics and System Fundamentals. The maker scene is alive and well. P-Tank is a palm-sized tracked rover powered by a Raspberry Pi 02, driving servos over GPIO PWM with a 3D printed chassis and a live camera feed. A responsive C# web interface keeps control snappy. It won't conquer outdoor terrain, but as a tabletop bot, it's a neat demonstration of how little compute you need for useful autonomy and telepresence. For developers optimizing any of the stacks above, it's worth revisiting Fundamentals. A classic post on myths programmers believe about CPU caches unpacks where mental models of caching go wrong and why performance intuition often fails at scale. As AI workloads stretch memory hierarchies and context windows, those lessons remain relevant. Measure carefully, avoid cargo cult micro-optimizations, and respect how real hardware behaves under load. And when you're ready to stitch perception, planning, and action into a local agent loop, higher-level tools are catching up. Langflow's Elephant Flow, with browser automation, code execution, and file system access primitives, is an approachable way to prototype agent behaviors before hardening them into production frameworks like Flow AI, or into decentralized hosts like PeerLLM, while keeping everything visible and testable.